I will say just some words before, okay?
Okay, sure.
Galera, falar em inglês. I would like to thank Andy. I got to know his work, and can you imagine we saved hours of coding, and doesn't matter what kind of front-end framework we're going to use. We just have to use the knowledge we know about Ruby and Rails. So this is his lecture today. I would like to thank Impulso, in the person of Natalia. Thanks, Levagon, the person of Chloe. Thank you a lot. All of you here today, and this is revolutionary. So let's pay attention. If we have some questions after the talk, we can ask them, okay? So a big round of applause for Andy Maleh, please. Go ahead.
Okay, so I'm gonna get started. Yeah, my name is Andy Maleh. Thank you for the introduction. I actually work as a senior software engineer at Eltropy, Canada. I have a master's in software engineering. I presented at RubyConf and RailsConf, and I won a Fukuoka Prefecture Future IT Initiative Award for Glimmer DSL for Web this year. And 3 years ago, I also won an award called the Fukuoka Ruby 2022 Special Award for Glimmer DSL for libUI after being reviewed by Matz, the creator of Ruby. So today I'll be talking about front-end Ruby with Glimmer DSL for web. And if you want, you can scan this QR code with your phone, and that will give you the slides, and then you can follow the slides on your laptop, or you can just check them out after the talk as well.
Andy, I think you are not sharing your screen. It's not showing.
Okay, thank you for letting me know. I'm gonna share my screen right now. Can you guys see my screen now?
Yeah.
Awesome. Okay, so yeah, there's a QR code on the screen you can scan, and that will give you the slides so that you can follow them on your machine if you want, or even after the talk. So let me see if I can, okay, good. So the project name is Glimmer DSL for Web. It's an open source free project on GitHub. Please star the project on GitHub so that you remember it and check it out later. It's basically a Ruby in the browser web front-end framework for Rails to build SPAs, meaning single page applications, in using front-end Ruby. So it's kind of like other front-end frameworks like Angular or React, except instead of using JavaScript, you use Ruby. It actually won the Fukuoka Prefecture Future IT Initiative Award, like I mentioned, after it was judged by Matz in an international competition. It runs on Opal Ruby. Opal Ruby is a Ruby to JavaScript transpiler supporting Ruby 3.1 and 3.2. The performance of Opal is very similar to JavaScript's performance because in the end it actually produces JavaScript, and that's what people receive when they hit a website built with it. And Opal also won a Fukuoka Ruby 2023 award from Matz, the creator of Ruby. So it's a very good project, very well accomplished project. I highly recommend checking it out. So Glimmer DSL for Web was built on top of Opal Ruby as a drop-in replacement for all JavaScript front-end libraries like React, Angular, Ember, Vue, Svelte, etc. It's actually better than all of them. I would say it's a lot better than React. Like React is the worst out of those, I would say, but it's also better than others like Vue and Svelte. Even the good ones in JavaScript aren't as good as Glimmer and Ruby. Because this provides a no-brainer upgrade in productivity and maintainability because we're using the language we all love, Ruby, which we already love in the back end, so now we can use it in the front end too. Sorry, my slides are sometimes not, I think it's Zoom. They're not clicking sometimes. Okay, it's clicking now. Okay, so first I'm going to start with a to-do MVC app. So this is a front-end app that is built and all, like, it's to-do MVC is basically a website that gives you the same app implemented in all front-end frameworks like React, Preact, Ember, Knockout.js, Can.js, Marionette, etc., jQuery. So you can see different versions of them. Like I can see the, let's just say the jQuery version, there it is. So I actually built it using Glimmer DSL for web and Ruby to demonstrate that you can build this app in Ruby. So basically it's just an app that lets you add to do basically, sorry, again, my mouse is having issues because of Zoom. I don't know why Zoom does that. Okay, so I'm adding items here in a to-do list, cleaning, shopping, fixing the deck, and then I can mark them one by one. I can filter by active or by completed, and then I can highlight the whole list. So let me do a live demo of it. So actually I have it on this link. So if we click here, there's a web-hosted version of it. I also have it running locally. There it is. So if I go here and then I click on to do MVC and I run it, this is the code in Ruby, by the way. It's just showing us the Ruby code. But if I run it, there it is. So I can just add items like cleaning, shopping, fixing, etc. Whatever, I can just add fake items too. And then this is me marking stuff as done. And then I can filter by things that are not done or see what's completed. I can also delete items. There's an X button here that pops up, so I can delete this. And if I go back to all, I can actually clear everything that's already marked done. And then I can also here check all the items or uncheck them. And if I check them all, I can clear all if I want. So this demonstrates to do MVC completely written in Ruby. So that was a Ruby version, what you just saw. So if we were to look at the top level code, the top level code of to do MVC is basically, it's a component. So it's a Glimmer web component. So this is a Ruby class. It's including Glimmer web component, which is a module mixin. And the key code is in the markup. So the thing that matters the most, which is the HTML, is the markup, except we write it in a Ruby DSL. So I have a div here, I have a section, and the DSL is very close to HTML. So like if you know HTML, you already know this DSL. There's a section, it's got a class, and then there are custom components. So I have a new to-do form, which is this thing. It lets me add a new to-do item. There's a to-do list, which is this thing. It shows me the shopping, cleaning, fixing the deck list. And then there's to-do filters, which are basically the filters at the bottom, like all, active, completed. And then there's the footer. The footer is what we see here. And this is all. This is the component, basically, and it has everything. And you can see how like super simple it is because of Ruby. There's like, at my job in the past, we used to use React, and React components were like super complicated because they had state management code, but in Glimmer, you don't have to write state management code. You hide all the details of data with a presenter or a model while following standard MVC, just as if you're doing Ruby with like MVC in Rails, for example. And then here it's super simple. There's no weird state management code. Also, it supports a CSS DSL optionally. So usually you can link to any CSS styles that are included in CSS files on the page. So if you want, you could do a CSS outside of here. But sometimes you might want to do CSS inside of here because you want to add some logic to it in Ruby. So you also have a CSS DSL optionally if you want. And then here, before rendering the component and after rendering the component, I can set up models. So I create a presenter that represents the to-do MVC page, and it has all the data stuff in it. And then after render, I can set up filtering routes, and then I can unset them up on remove of the div that is at the root of this element. So, I mean, this is in a nutshell, this is the whole thing, like the whole framework. But of course, there's a lot more to it than that. By the way, the filters that I was talking about were if we were to go back here and go back to do MVC and add elements, when I click active, notice here how it added active at the top as a URL. That's a front-end route. So front-end routes could be set up. That's what that was. Okay, so let's take a quick look at the code of to-do MVC. So I have it open here. There it is. And what I'll do is I'll go here and go back to the code of the top level code. There it is. So by the way, this app was also built with the Glimmer DSL for web. So what you're seeing here is also front-end Ruby. This is syntax highlighting done in front-end Ruby, by the way. And so this syntax highlighted area is showing us the code. So we have the markup. So the first thing we're going to look at is the new to-do form, which is this part. So yeah, this is the new to-do form. So if I go here and I go to views, so here you just have components like any other framework that in JavaScript that supports components. Also Glimmer supports components. So I have a new to-do form. There it is. So if you look at it, it's a very small component. It's just a new to-do form. It's got markup that basically has a header element in HTML, an H1 element, and then inside it has another component called new to-do input. So basically you can require other classes within your code and divide your code that way. So now let's look at new to-do input and see what it's doing. So new to-do input is basically just an input field. It's got a placeholder that says what needs to be done. So that's the message that shows up here, what needs to be done. And then here it's using bidirectional data binding in one line, which I'll cover later. But basically what it's doing is basically it's data binding the value of this input. So here we have value, and it's doing bidirectional and sending it into the task attribute on a new to-do model. So the presenter has a basic Ruby model. That's the nice thing about Glimmer. You can just write basic Ruby for the model layer, and then it has an attribute called task, and here I'm binding it to the input. So that means if I type anything into here, it's gonna automatically get stored on task on new to do. So to show you what I'm talking about, let's go to the presenter layer and look at to do presenter. And if you look at new to do, it's creating a to-do model here. So now we can go and look at to-do model. So I'm going to go back here, models, and there it is. So the to-do model is just a Ruby struct. You can build it as a class, or you can take advantage of Ruby features like struct, which lets you build a model very simply with just one statement, adding all of those attributes. So the attribute that we care about is the task name, or what is the task of the to-do item. So that's the one that we're data binding. So that means that here when I type 4, for example, or let's just say cleaning, that's the task, it's going to automatically copy it into this attribute on this model in Ruby. So that way it simplifies data management significantly. I don't have to worry about data management. I just declare at a higher level what I want to be bound to the model, and the Glimmer does it for me automatically, so I don't have to worry about it. So the code remains simple, super simple as a result. So if I were to go back to, let me open an IDE. It's quicker to look at it in an IDE. So here's an IDE. By the way, this is Gladiator. It's an IDE that I built in Ruby using my other Glimmer library, Glimmer DSL for SWT. So let's look at lib here, samples, regular, to-do MVC. So this is the to-do MVC top level code, and then we dig into components. So we already looked at new to-do form, so let's look at to-do list. So to-do list, the markup of it just has a div and then an input and then a label, mark all as completed. Okay, this input is a checkbox actually. So this is a checkbox. So this is basically what we saw here, this thing. It lets me check everything if I want. And then here I have a basic, like it's HTML, so it has an unnumbered list. And here it basically is listing the to-do items using a to-do list item component. So now I can dig into to-do list item component, and if I look at the markup, by the way, I have a lot of comments because I'm trying to help people that are reading the code understand what's going on, but normally the code would be a lot less. It would be like this. Like, we don't need any of those comments, honestly. This is just in the open source code. It's just helping people understand what's going on. But for every to-do item, it could be it could get completed, or it could be active, or it could be editing. So that means if I go here, for example, right now it's completed. If I do this, it's active, and if I edit it, I can actually edit it and say 1, 2, whatever. In that case, it's actually editing. So here I'm using CSS class data binding. Basically, I'm saying if the model, the to-do model, completed attribute becomes true, automatically mark the CSS class as completed, and that will automatically enhance the element so that it looks completed. So as soon as I click this button, the to-do model will get marked completed, meaning if I open here to do RB, let's see. Yeah, these attributes that are declared in Ruby, this is going to contain automatically a true value as soon as I click on this button. And as soon as it becomes true, here there's an arrow that's going to the left, so meaning copy this value automatically to a CSS class called completed. So it sets it on the element, and basically with very little code, like just tiny bit of code, I was able to achieve this behavior. Of course, I have CSS that describes what happens on completed. So here below, I have a CSS declaration for completed and how it changes the color. And it could be done in a different file. I have it in the same file, but you could do it in a different file. But either way, this automatically handles basically changing the state of the view so that it happens automatically on changes to the model. So here it's basically double click start edit mode. So like when I double clicked it, it started edit mode, and I can change this. I can make it 5, for example. So this is just here. Any events that are available in HTML, they're available in Glimmer. So if I have on click, on double click, on up, on key down, etc., anything that you were able to do in JavaScript with HTML, it's possible to do here. You just use the same syntax. So if you know HTML and JavaScript, you already know Glimmer. There's not much to it. Like for example, here we're using an on-click button for destroy. So this is basically when I go here, there's a destroy icon. I don't know if you can see it. There it is. Here, this X, and then I can click it and it deleted the item. There was one more thing that I didn't cover. Let me see. The filters. Let's look at the filters. So the filters are in the to-do filters component, and it basically it has a list of the filters here. So again, it's just basic HTML. We have a footer, we have a style tag, style data binding, a span, etc. It's just HTML. And then here for every available filter, it basically will render a list item with a link. And then here on click of the link, it will set the filter as the one that was selected. So basically this is saying when I go here, let's just say we run the app and I select here, and then here when I click active, this is here, this on click button. When I click, this will happen. It will basically set the filter as the active one. So here I'm going to change to active filter. So now I only see active elements. Here I'm going to change to completed. So it's only showing completed tasks now. And then I can reset the filter to all, and now it shows everything. So this is basically this one line of code. That's what's amazing about this, is once you do the data binding, you don't write much logic. You write like one line of code. Like this is unheard of in React. Like when I work on React code that's done, like implemented by my coworkers, it usually has so many lines of code to do something simple like that. So anyways, I think that shows you, that gives you a general idea of the DSL and how Glimmer DSL for web works. Basically, we end up writing so much less code with it that when I took a React component at work and refactored it to Glimmer, it went down from about 1,000 lines of code. No, it actually went down from about 450 lines of code to about 45 lines of code. So it became 1/10 of its size. And most of the state management code, all of the state management code went away. It became just basic Ruby models, like basic OOP models, nothing special. So this is basically a huge advancement in front-end development compared to something like React. Like it's not even close. So that's the reason why I built this project. But so why Ruby in the browser? We want to improve developer productivity with an isomorphic application architecture that enables using the same programming language on both the front end and back end. So we already love Ruby on the back end. It's a very good language. It is better than JavaScript for sure. That's why like at my job, we use Rails. We don't use Node.js for the back end. It's because we know Rails and Ruby are more productive. So why not use it on the front end as well? Ruby is actually more productive on the front end too. It's just people haven't been taking advantage of that. So this is so that's why I built Glimmer DSL for web, is to take full advantage of Ruby in the front end as well, because Ruby is an excellent language for that. Significantly better front end code readability and maintainability, especially using Ruby unique features like blocks and operator overloading. Like Ruby has very cool features like blocks, which look very natural when reading. It's like reading English. It's not like in JavaScript where it doesn't feel like reading English. So that's another advantage to Ruby. And honestly, JavaScript is just an awful and confusing programming language. I mean, everybody knows it was built in 10 days for the original version. And it has loose typing, which confuses things. It makes maintaining the code a bit complicated or surprising, especially for new developers. And also, even despite all the ECMAScript releases that came out, like 2016, 2017, 2018, whatever, it's still not as nice as Ruby. Like when I write code like this, I can do it more nicely in Ruby like this. So Ruby is still a much nicer language than JavaScript. So people who claim that JavaScript could be the right tool for the job, they're wrong actually. Ruby is the right tool for the job here for front-end development, but people have just not been taking advantage of it. So Ruby meta programming facilities are also superior to JavaScript. Everybody knows Ruby is amazing. You can build things in it like RSpec. So there is an RSpec version for Opal Ruby, by the way, that runs in the front end for people to write Opal Ruby tests, like unit tests, or do TDD for front-end code, not just back-end code. Also, Ruby's ability to build DSLs enables doing declarative creation of HTML. Kind of like I showed you an HTML DSL earlier. This is like a way, like this is from another library called Ineseta that's built in Opal that also has an HTML DSL. But I mean, this idea is not new in Glimmer. There were other libraries before Glimmer that did this. But Glimmer is also taking advantage of it. Like the idea of HTML DSLs is a very useful thing because it simplifies mixing logic, like each with index, for example, with declarative data, like list items, for example. We can write them in the same language. So for example, using Ruby code like this, it generates this HTML. So you can see this is not dry. Like for every list item, I'm having to repeat li twice. Whereas here, I just say li and I open a Ruby block. And I put the name here and then I close the Ruby block and it figures out how to add the closing li automatically for you so that you don't have to do it yourself. So again, it's not even close to how, this is so much more productive than even ARB or like other Ruby ways of building front-end stuff, but obviously it's way more productive than JSX and React as well because we're not using, we're using something lighter than HTML, which is a Ruby DSL. Ruby has better core APIs or libraries, it has a better core libraries than JavaScript or APIs for like array, hash, enumerable, string, symbol, etc. It's just a nicer language with that regard. JavaScript libraries could be also reused from Ruby. So anything that's available in the JavaScript ecosystem, you can use it from Glimmer and from Opal Ruby because and you can use it with better syntax. So for example, this is jQuery, and I'm using jQuery using Ruby code. And like after you grab an element, you can write nice Ruby code like reject and select and stuff like that, which is amazing. Like combining the advantages of Ruby iteration with like the capabilities of JavaScript is just so cool. So like it's so productive. Also, the ability to reuse Ruby gems in the front end. So I've been able to successfully reuse a lot of Ruby gems in the front end. including the Glimmer engine. So Glimmer used to be originally a desktop development library for Ruby, but I took the engine of it and I was able to reuse it in the front end, and that's how I built Glimmer DSL for web. And all thanks to Opal Ruby. Opal Ruby is amazing. It's like very, very close in compatibility to real Ruby. Honestly, I generally, most of the time, I don't feel the difference between them. Also save development time by sharing, reusing Ruby code between the front end and back end. So generally, one problem with using JavaScript in Rails apps is that every time we have back end logic, like doing tax calculations or price calculations that need some special logic, if like in my team at work, you know, I see front end developers often repeating or re-implementing back end logic in the front end. Because sometimes they don't want to do an API call to the backend, so they end up re-implementing Ruby code in JavaScript. Whereas in Opal Ruby, you don't have to do that. You can just actually take backend Ruby logic and use it directly in the front end. And if you do that, you don't need to make an HTTP API call. So you can provide a more user-friendly experience to users that way. Of course, you don't want to re-implement everything, like you don't want to expose everything from the back end. You just want to expose logic that does not compromise software security. So you can always pick the things that are okay to be shared with the front end and hide the things that are not okay to share with the front end. So that way you ensure software security as well. Lastly, transfer developer Ruby skills from the backend to the front end. That's a very big one. There are a lot of Rails developers that are back-end developers only because they hate front-end development with JavaScript, because JavaScript is such a terrible language, and they don't want to like restart their learning and learn everything again from scratch in JavaScript. So they end up being just back-end developers. But this now opens the door for all Ruby back-end developers to become full-stack developers. And everybody knows, like in general, if you can be a full-stack developer, you'll be more effective in development because you'll be able to understand the value that you're giving to the user end-to-end, all the way from the front end to the back end to the database. So this is a huge advantage. And also it enables companies to cut down their workforce by half. So they don't need to hire front-end developers separately anymore. They can have their back-end developers do the front end because Ruby's so like cool and fun to use that back-end developers will be more than happy to use it to build the front end as well. So now, how do we solve this problem? So I mean, I talked about the benefits of Ruby in the front end using Opal in general, but like how am I approaching building a framework for it, which is called Glimmer DSL for web? So I have a number of design principles that I wanted to preserve in order to break away from all the JavaScript libraries. Like all the JavaScript libraries have the same flaws. I mean, they rely on JavaScript, which is a problem that's a language that is very flawed compared to Ruby. But there are other flaws in JavaScript, like I'll go over them in a second. So for example, the first thing is I want to follow the Ruby way. So in Ruby, one principle is there is more than one way to do it. So for example, if you have an array, you can call for array.size or array.count or array.length. And all of them will give you the length or size of the array, which is very user-friendly, like it's programmer-friendly. That way, if you forget whether you want to use size or length, all of them will work. So I want something that provides something with the same programmer friendliness as Ruby, which is not available in JavaScript. Next, I want Rails, the Rails approach of convention over configuration via smart defaults and automation of low-level details. So in Rails, a lot of things are automated because of convention over configuration. So I want the same thing. One big problem in JavaScript is, for example, if I want to configure Webpack, it has so many options, so many settings. I end up wasting like weeks just setting up Webpack, whereas here we don't have to worry about that. Next is requiring the least amount of code possible to build highly interactive web pages. So I'm actually coming up with I want the simplest possible syntax that we can do in Ruby. Next is declarative syntax that visually maps to the DOM. So I already showed examples of that. By the way, like libraries like React, they claim to be declarative, but in the end, they tell you to write render. You have to say render, which is imperative. So they're kind of lying to you. It's not exactly fully declarative if you're saying render. Whereas here, it is truly declarative in Ruby, using Ruby DSLs. The ability to mix declarative and imperative code conveniently in one language. So this is something that's not available in JavaScript because unless you mix languages. Whereas here, we don't have to mix languages. We can work in one language, Ruby, and be able to have declarative and imperative code at the same time. We want computers to serve software engineers, not the other way around. One big problem in React is that it's so complicated with its state management approach that it requires the engineers to translate everything into functions and then think in a functional way at a low level. Unlike the real world, when I have a real world and let's just say I have a car and I want to turn the car on, I just turn the key in the car, or I press a button if it's a more modern car, and it turns on automatically, but I don't think about functions or math. In reality, nobody thinks about functions or math. So why are we forcing the software engineer to translate to the computer things into functions? Here we don't do that. We just use Ruby. Ruby is OOP, it's amazing, it's like the closest thing to English. We're gonna do the same thing in Ruby, in the front end now. We want to think only about real world concepts like web page interaction and application domain. So again, I don't want to worry about state hooks and effects and stuff that is not relevant to the business. I only want things that are business concepts. Like I showed you, like to do items, they could be active or completed. And the code in Ruby was exactly that. Like I had an attribute called completed and an attribute called active, and that's exactly what they represented. Also, I can change it into editing mode or non-editing mode. So again, the code reflects reality directly. Modular software design, so that means I need to support components. And the last one is no premature optimization. That's a very big one. Like if you go and browse, if you go to the Rails website, like the Ruby on Rails webpage, everything they'll talk about is about productivity, maintainability, how to write code that is very like flexible and like easy to maintain and extend. Whereas if you go to any JavaScript web page, the first thing they will talk about is performance and efficiency and stuff like that. But like I wonder, I'm like, I built many web apps for businesses, and I've almost never had performance issues in JavaScript. Like most of the time, performance issues are in the back end with database related problems, like not having indexes or doing the wrong kind of joins and queries or stuff like that. But honestly, for most business apps, if it's not Facebook that you're building, you're not going to have performance issues. JavaScript is fast enough for most problems. It's not an issue. So why are we talking about performance? Almost all the JS libraries talk about performance first, even though it's not important at all. All my web pages that I built in JavaScript for businesses over like 20 years of my career ran in less than half a second, I would say, in general. So like sometimes they run in less than a second. Still, they're not really that slow. Usually you want to be between half a second to a second to be fast. But I've even built pages that ran in under 300 milliseconds or even less. So why are we worrying about performance? So that's a key problem that complicates JS code. A lot of libraries like React are more complicated than necessary because they have premature optimization, probably because it's used for Facebook, but most businesses are not Facebook, and it's not really needed, honestly. So it's a waste of time, and it makes you do double the effort to develop. So we want to avoid this problem. So the thing that I came up with is Glimmer DSL for web. And one of the first things that it supports that is not supported in JavaScript is being able to write logic, structure, and style in one language. So for example, here I have a table that's written in HTML. So that's structure, HTML structure. It's got a T-body under it. It's also structure. But then here I'm looping through samples in my sample selector app that I showed you earlier on a presenter model. And then I want to take each sample and render its name. So again, we go to logic, but I'm still in the same language. And it's super simple. Like the code is super readable. And then now I'm in a TR structure element again, and TD structure element, but here it's accessing the model in the same language, which is amazing. And then here I have an on-click listener, and it's using a Ruby block, so there's a bit of logic here, which will do something when I click the button, but I'm still in the same language. and it's like all compatible. Like the whole language is compatible. Like all the structure and logic code is compatible with itself. Like it's not like when changing between JavaScript and HTML. Here we're still writing Ruby. We're writing Ruby here and we're writing Ruby here. Finally, we support a CSS DSL. So if I open a style element, I can put CSS directly in it and I can write it in Ruby again. And this is using a Ruby DSL, like R means rule. I'm creating a CSS rule. This is the expression of the rule, and then inside it I put the properties, so like border, padding, cursor. And here I can use, and the cool thing is I can actually pass it variables from a model. That's like unheard of. Like usually with basic CSS, you cannot mix it with model data. But here it's the same language, we're in Ruby, so we have a unique advantage. And the code is like super readable. So that's one of the key advantages that improve productivity significantly, is staying in the same language. Next thing is we don't waste time. I already demonstrated this, but this demonstrates it even better. We don't waste time switching between languages in the same file. So ERB tries to let you mix Ruby logic with the structure. But see here, I'm in HTML mode, and then here we're switching to Ruby, and I have to open a scriptlet, which is incompatible with that kind of code. It's like annoying. And then here I go back to HTML, and then I have to go back to a scriptlet, and it's just, I'm writing way more code than necessary. In Ruby, in Glimmer, that's how you write it. You just say a table, t-body, and then boom, we don't need a scriptlet. We are already in Ruby, so I can just write Ruby code and continue in Ruby. And then here I go back to structure again, but I'm still in Ruby, and it's all dry. Like there's no repetition of TD and TD, TR and TR. Like here I just use a Ruby block, and Ruby will automatically figure out to do the rest for me, like generating the correct HTML behind the scenes. So behind the scenes, Glimmer will generate real HTML, and that's what people will get in their web page. But when you're writing the code, you write it with the simplest code possible. HTML is not the most dry language available. So here we have something more dry that lets us more fluently switch between iterators, data, and structure, which is amazing. Next is, so this is the code when it's in HTML DSL, and this is when it becomes HTML. Like I mentioned, it generates real HTML behind the scenes, and it even supports SVG. By the way, the library also ships with a command that lets you convert any old legacy HTML into Ruby HTML DSL syntax. So that way you don't have to write all of this right away if you're converting an old feature. You can just run a command that will convert this automatically to Ruby code for you. So the first concept you want to learn is element keywords. So when I'm using the DSL, for every element I have a keyword, and it's exactly the same keyword you use in HTML. So if you know HTML, you already know Glimmer. It's declarative, and it's a Ruby method behind the scenes, but you don't care. Like you're working under the illusion that this is just a declarative DSL. You don't care that it's a method. But yeah, I mean, it could be HTML, head, body, form, input. Anything that's supported in HTML is supported in Glimmer. Option, select, table, t-head, t-body, tr, th, td, etc., etc., etc. Obviously, the full list is online. Oh yeah, and also custom components like contact form, contact table. Like I can create my own keywords as well and add them to the DSL. The DSL supports automatic expansion with new keywords once you declare your own custom components. So, I mean, you can find the full list online, obviously, but all of them are supported. The next concept you need to know about the DSL is arguments. So arguments let you pass HTML attributes, basically, or text content as well. So let's see. So if I pass a string only, then it counts as the text content. So if I'm declaring an H1 header, this is the content of the header. But if I pass hash attributes in Ruby, they become attributes on the element. So this element is going to have an ID of contact form and a class of header. And that's it. It's very, very similar to HTML, basically. This one is combining both. Like a label has the text content of this and for attribute of this. So this is a bit similar to ERB helpers in Rails. So that's how we do it in Glimmer too. Next is the content block. So you can use Ruby blocks, And when you're doing declarative syntax in Glimmer, doing structure, it's recommended not to do end, because do end is imperative. Here we're intentionally using braces, and we're actually having our own standard, different from Ruby's standard. In Ruby, usually you use braces only if it's on the same line. But here we're going to use them on multi-line content to indicate that it's structure. So that makes the code simpler in being able to parse and figure out what's structure and what's logic. And usually you open this block and then you can put in it properties, event listeners, nested elements, or string content. So here I have a div, it has a property of inner text, and then I can set it to a value, like the content of an article. Or I have an input that has these attributes, but then inside it, it has a value property, and then I can set it to user.email. This is here me combining an element with attributes and properties. And obviously, any HTML DOM object properties in JavaScript are supported in Glimmer. So anything that you would find online should be supported in Glimmer. Next is listeners. So you can add any listeners that are available in JavaScript in Glimmer as well. So they always begin with the on prefix, like on click, on key up, on key down, etc. They follow the observer pattern. And this is an imperative block of code. So here we actually use the do end version of a Ruby block because we want to say on click, do this. So this makes perfect sense here because we are being imperative here. Whereas here we are being declarative. We're saying the button inside it, I want to declare the content of the button, and it has a listener of on click. So this is what I meant earlier by being able to mix declarative with imperative code. But Ruby is such an amazing language, it makes it so effortless to do that. And it's so readable, like it's amazingly readable. This is a more complicated example, but like I have an input, it's got these attributes, got this listener, and then here it's doing some work. It's it's grabbing the input fields as objects, kind of like JavaScript objects, and then it's checking their validity. So anything that's available in JavaScript as a method on an object is available in Glimmer as well using Opal Ruby. So like kind of like prevent default, we all know prevent default, but in Opal Ruby they support the Ruby standards for naming. So instead of having prevent and then capital D for the default like in JavaScript, we write it the Ruby way. And then here it's invoking add contact on a presenter in Ruby, and then it's changing the focus to one of the elements that are declared on the page. So one key thing that's not available in frameworks like React is we can assign any of those elements that are in the DSL into a variable in Ruby, like an instance variable. And then you can call methods on it like we did here, using some advanced Ruby stuff, and then it works, it just works, which is amazing. These are all examples of listeners available in Ruby: on key down, on key up, on mouse up, on mouse down, on copy, on click, etc. Finally, we can nest elements. You already saw that. So a table has a tr in it, and then a tr, which represents a row. A table row has td, meaning table data, which is for a single cell. So it's a declarative hierarchy. It's the composite pattern for people that know about design patterns. And this is another example. A form has a div, which has a label and an input, and it's all declarative. That's what's cool about it. This is also the same thing. Here it's showing that if I don't have content that is other elements, you can also put strings. So if it's a paragraph tag, like a p tag, you can put the string as just a Ruby string. If you pass a Ruby string into this block, it will set it as the string of the p. This is the same as passing it as the first argument for p as well. So you can do it either way, but this is one way of doing it. And you can also call other tags like strong or em inside the string that you're setting inside p. So that enables you to basically nest tags within the text of a tag. Okay, the last thing is element methods. So like I said, once you have an input object, I can assign it to a variable, and then this instance variable, you can call methods on it like check validity, which actually are invoking JS DOM methods behind the scenes. And then I can grab its value, and then I can make it grab focus. So this is all possible thanks to Opal Ruby. but you write Ruby code instead of JavaScript. Some elements have extra methods that Glimmer adds, like content. Like I can reopen the content of any element and add more stuff inside it. This is kind of like open classes in Ruby, but this is open content on elements in Glimmer. So yeah, any methods that are available on elements are available in Glimmer. So let's go into more advanced stuff. Like in real apps, we want to follow MVC pattern. So there's a view that observes the model for changes and then it refreshes itself. There's a controller that receives events from the view and then manipulates the model. And the controller will observe control things like mouse up, key up, selection, etc. Whereas the view will observe data changes on the model. So like, did the completed attribute change? Did the active attribute change, etc. So this is basically MVC pattern. It's the same pattern that we use in Rails. Okay, so observer design pattern is foundational. It's very important for building user interfaces. In Glimmer, if I want the view to observe a model, it gives you something called observe keyword that lets you observe an attribute on a model, and if it changes, it triggers a block that will let you update the view. But either way, let's start with an example. Hello observer. So the model is just a number holder. It's just a class that has one attribute number, and it initializes it to 50 when it starts. So that way here, when I start, it's 50, but then I can play around with this thing, and then it changes it. And then I can play around with this thing as well, and it also changes it. So whether I change it with the spinner or the slider, it will change. But they're both data bound to the same element, so they both change. So one way of writing this code is, for every component, there's always a markup. Markup is the declarative code. Before render and after render is imperative code. But the markup basically has the key HTML elements that are for this component. So I have a div and a div. What matters here is we have an input, which is the number input, meaning the spinner. And then we have another input that's a range. So that's the slider. So one of them is this and one of them is that. And we're saying here on input, meaning if the person changes the number, go to the model, like number holder number, and update it to the value of this input field. Here we're doing the same exact thing, except it's from the range field. And then here we have an observer set up for the view following MVC, where this hello observer component is actually observing the number attribute on the number holder model. And if it changes, it goes and updates the element that was not updated. So here's saying if the value of the element is different from, if it's not equal to this new value, then update it. So that's what's making those two values be in sync. When I change this, it changes that. When I change this, it changes that. Of course, this is the MVC way of writing this code. There's a better way of writing this code, which is the data binding way of writing this code, which I'm going to cover next. So data binding relies on a more advanced pattern called MVP. So I have a view, I have a model, and I replace the controller with a presenter. And the presenter kind of decouples the view from the model, and basically it observes both sides. And if the model attribute changes, it automatically updates the view property that corresponds to it, like the value of an input. And if the value of an input changes, then it automatically updates the attribute on the model, like the number on the number holder or the value on the number holder. So I can just do this. Like I can say input type text, for example, or it doesn't matter. It could be range, like I showed you earlier. And then here the value is automatically data bound to name on contact declaratively. So this is the declarative way of doing what I just showed you. I showed you what I showed you earlier was more imperative. This is more declarative. Look at how much shorter it is in code. It's only these 3 lines of code and we're done. Honestly, it's just this one line of code, that's it. This line of code is doing most of the code I showed you earlier. And here I do the same thing for the other input, and now they're in sync. So this is unidirectional data binding. If I only want updates to come from the model to the view, but not the other way around, like if I'm updating the text of a div, because the text of a div does not give the user control over it, but it gives the model control over changing its attribute. So you can use unidirectional one-way data binding in this case. And this is the beauty of Ruby. It has operator overloading, so it supports the syntax. And also you can add converters. Like I want to convert the value on read from the model. So as soon as I read it, I want to take the value and add text to it. So I can use Ruby lambdas and basically convert it into this value. I can do style data binding. I can do class data binding. There's a lot more advanced versions of data binding that are supported by Glimmer, but I'm not going to get into all of them right now. Some of them are supported by JS frameworks like Vue.js and Svelte, I think. But obviously Glimmer syntax is Ruby, so Ruby's nicer. So now let's look at the data binding version of the same example. And there it is. All the code that was in the after render disappeared. Like there were here 5 or 6 lines of code, maybe more, under the after render block. We don't need it anymore. It's all gone. We don't need to have the view observe the model manually anymore. We can, using an observe keyword, we can now just do data binding, like link this to that, and we're done. So this one line exactly represents what I'm thinking in my head, like the simplest thing that I'm thinking of. When somebody's trying to think about the view, they think, okay, I want the value of this input field to be tied to the number on the model. And that's exactly the code we're writing. And this is here the same way. And if I want it bidirectionally, I use the bidirectional arrow in Ruby, and it works. So that's that. Let me do a quick demo of it here. Let me close this. So if I go back here, I go to Observer Data Binding, I run it, and there it is. I mean, this is what I talked about. It works, but yeah, that's this is the short version. This is the longer version. So yeah. In real app development, you usually want to do the shorter version, obviously, but sometimes the longer version is useful for other things, for more advanced cases of implementation. Next thing is content data binding. Content data binding is re-rendering, basically. So if I have a block of HTML content that I want to get re-rendered on changes to a model, you can have basically in MVC or MVP, basically listen to changes on an attribute in a model, and as soon as it changes, it re-renders this block. So here, for example, I'm listening to the change of how many addresses I have. I only have 1, but as soon as I change this 1 address to 2 or 3, it's going to re-render this entire block. So see, now I changed it to 2, and it gave me a second address form. So this is basically content data binding. It's basically binding the content of an element to a value on a model. So that's what this is. And basically you just open, if I have a div and I want to bind its content to the addresses on a user, you just do that, and then you write the code normally here that you would render from the addresses of a user. And as soon as this changes, like if I change the address count here, it's going to add a new address to the user addresses array. And as soon as it adds it, it'll automatically re-render this part and show us on the screen what you saw. So this is content data binding. Next is components. So Glimmer supports components. You can build your own components. That's the real way you want to use Glimmer in real app development. At my job, we actually built this component, for example. So yeah, you can do pagination components, different stuff, a search field component, tabs, etc. So like if I build an address form, it's a very, very common component. You know, you have all of those input fields that corresponds to those input fields on the screen, and they're all data bound to a model very simply, very little code. Like see, there are no state hooks or effects like in React. The code here is way less than React. It's like insanely less. Like there's not even any state management code whatsoever. And here I just have declarative data bindings, that's it. But here, then I reuse this address form in a different page, in a different component, using the address underscore form keyword. So automatically, if you declare a class like this in Ruby, so Glimmer does, like Rails, does convention over configuration. So by convention, it's going to generate an address underscore form component, and then here I can use it. And then if it takes here an option of an address, here then it means I can pass it an attribute of address here. And that's it. I was just able to reuse the address form twice and pass it to different models, a shipping address and a billing address. So again, the code is like amazing, like so little code, and like it does everything I want as far as data management automatically using like observers and data binding behind the scenes. And here I have another one. I mean, this is the same thing. It's just displaying what we see on the screen. That's it. But you can see here, there are 2 different addresses, but they're reusing the same exact component. So you just include the Glimmer web component into a class to declare a component. And then you define options, or you can call them attributes. So I could have used the word attributes instead of option. Both are supported. So this is like the Ruby more ways than one to declare something. Kind of like how array supports length and size. Here I support options or attributes. And then I open a markup block. So this is fully declarative. There's no render. Like I don't say render. I just say, oh, you know, here's the markup, and I give it the HTML. And then if I want to add before render logic or after render logic, now that logic is imperative, but it's different. The key content is declarative, but if you have to do extra stuff, you can do extra stuff imperatively if you want, because you might want to combine imperative paradigm with the declarative. This is how to do things before rendering a component and after rendering a component. After rendering is usually to register event listeners if needed. And finally, I take the class and I call render on it and automatically render it on the screen. And I can pass it options like who is the parent that it'll render it under. And you can render a component under a specific parent. So I just give it the CSS expression for where the parent element is, and it'll render the component inside it. Like something like this, like put it inside container. So the container could be pre-rendered in an ARB template from the back end, and then in the front end, it runs this code and then it puts the component inside it. But this is not the way we usually write apps. The way we write apps is simpler than this. I'll show you how. Markup root is just a method that gives you the root of the markup, the root element. Component slots is a feature that lets you customize components. So if I want to create a component and follow the open-close principle, where it's open for extension but closed for modification. For example, I can create an address form that can take a header that it will insert between the title of the address and the fields of the address. So this header is customizable. So that's a slot. So Glimmer supports component slots like address header and address footer. So slots is a feature that's available in the HTML web component spec, and it's also available in the Vue component library in Ruby. So Glimmer supports it too. It lets you be able to customize any component so that you're not limited by how the original authors of the component envisioned it. If they open for use slots, you can contribute to the slots any content you want. You can even designate a default slot, like for example, an an address form. If most of the time people are going to populate the header and ignore the footer, then you can designate it as the default slot. So people can put the header stuff inside address form, and this will automatically go into the header because it has it set up as a default slot. If it's not a default slot, then all you have to do is open the name of the slot, which is address header and address footer, underneath the component. It's that simple. It's like super simple. So, like this feels like just another HTML element, honestly. Otherwise, or you can designate a default slot if you want to make the syntax even shorter. Custom listeners is about any component can have its own listeners. So like just how I showed you, a button has an on-click listener, for example, in HTML. If you build your own component, and I have a section in an accordion widget, accordion element or component, every accordion section has an expanded listener event and a collapsed event. So you can declare your own events, custom events, and take advantage of them. So yeah, that's what custom listeners is. Also, you can have custom attributes. So if you declare any attributes or options on a component, I already showed you earlier a component that had an address option. You can then actually data bind to them. So if I have a component here and I declare the custom option on it, now this becomes just like input view was data bindable. This is data bindable too. I can data bind the address of a form to an address on a presenter, and if this changes, the view address on the component will automatically change here. So yeah, this is also very amazing. Like it shortens the code that you have to write for apps by a lot. Finally, this is the way to use components in Rails apps. So in Rails apps, we usually call the Glimmer component helper, and basically you have to include Glimmer helper into application helper, and then it gives you this. And then here, this works exactly like the React component helper that comes from the React library for Rails. So I just give it the name of the component, the top level one for the page, and I give it attributes. So you can preload it with any attributes you want to preload, and then it'll actually render it. And once it renders it, from that point on, it's handled by Glimmer. That part of the page is handled by Glimmer. Kind of like how, so this part is basically an SPA, a single page application. And it can manage everything on its own going forward using Glimmer with Ruby on the front end, whereas the rest of the back-end code is on the back end. So that's that. Oh yeah, and then so people can create their own component libraries if they want and include their own components. So like one company might have e-commerce related components, a different company might have fintech related components. I actually created my own general components, which I'm extracting into it components from my work app, my jobs Rails app. And I created this component called multi-checkbox dropdown, which we needed in my job. So like this is the dropdown, I click it, it gives me statuses, and then I can select multiple statuses. And once it selects multiple statuses, it shows you here the names of all the statuses are selected. And they all get stored into this attribute, into values on the component, which is a custom attribute. And then I'm data binding it here to status filters on presenter. And then the presenter is basically a Ruby model. It can do anything with this data once it gets there. And that's it. So this is, the project is here, I believe. I have it open somewhere. There it is, Glimmer Web Components. I plan to add as many components as I extract from my jobs app, but this is just one library. People can create their own libraries. Like anybody can create their own library on top of Glimmer DSL for web and add their own components. That's the goal, just like what you do in any other libraries like React or stuff like that. This is Glimmer supporting paragraph formatting, which I already kind of showed, and being able to nest B or EM inside the characters of a paragraph. I already showed an example of that, so we don't have to get into it. Okay, CSS can be handled in one of three ways. You can either use the built-in Glimmer Ruby CSS DSL. It's actually fast enough in my experience for very little, like if you're rendering a little bit of CSS, it's very fast, but keep in mind that this is getting rendered at runtime when you load the page. But in my experience, rendering is happening in less than 300 milliseconds, more often than not. I mean, often in my experience in general, actually even less than 200 milliseconds sometimes. So this has been fast enough. But if there is a lot of CSS, you can actually just link to any external CSS or SCSS file, because Glimmer in the end produces standard HTML. So it'll work with any CSS or SCSS framework that you have outside of Glimmer. You can even integrate with Tailwind or Bootstrap or any library or any grid system. You can do anything you want with external CSS. Or you could do a hybrid approach. That's what we do at my job, actually. We have external CSSs or CSS files that have general styles. And then if we have specific styles that have to change for a specific component, then we change them in a Glimmer CSS DSL. And that's definitely fast enough in my experience. Like I didn't notice any slowdowns in it whatsoever. So I do recommend this approach if needed. But obviously, if somebody prefers to keep a CSS external because maybe they have a different team maintaining the CSS, they can definitely do external CSS as well. This is the CSS DSL. It has Ruby niceties where you can say 1.1.em or use symbols for strings, or you can do 90%, and it automatically converts to the CSS equivalent, like 1.1em, white, 90%, etc. Or you can pass it as you can pass it as string, and it'll preserve it. And anything that's dash here by convention. So again, convention over configuration. Here it's underscore in Ruby and the Ruby DSL, and that's it. It's that simple. Oh yeah, and it supports media queries. So yeah, that's it. I've already explained it. The last thing is web requests. So it's important to be able to make calls to the back end. So there are multiple ways of doing it. Glimmer ships with Rails resource service class, which lets you be able to call Rails RESTful CRUD operations like index, show, create, update, destroy for any model by only passing in the model argument at minimum. And it can figure out the rest, like the URL and stuff like that, and how to pack that parameters for you. I'll show an example of this in a second. A second approach that's more advanced is to use the Opal jQuery gem, which supports jQuery Ajax via the HTTP class in Ruby using Opal Ruby. So this gem is already included in Glimmer DSL for web, so you can just require it and use it. Or we can just reuse the JS web request library like Axios, or we can just use built-in JS fetch if you want. So all of those are supported. So for example, if I want to use Rails resource service, that's the simplest way in my experience, is I take Rails resource service and I say, I have a form contact and its data got updated, but I want to update it on the back end. So I say, call update and pass it the resource as the form contact. It'll automatically make a call to the back end and submit the form contact for you to the Rails route correctly. And then here it'll give you a response. And here I can check if the response is okay, meaning no validation errors or something like that. Then I can take the updated contact and I can set it on a model, whatever model I'm using, and clear the errors of the page and reset the form. Otherwise, if there are errors, I can set the errors on the contact page, and that line alone will actually display errors on the screen because of data binding. But yeah, basically this is it. Like this is handling all the logic for calling the backend to Rails. So I used it to build this app contact manager, and this is update contact, the button, which if I update a contact here, which is selected here, then when I click the button, it's gonna actually make that call using the resource service. So if I go here and I go into contact manager, which is one of the samples, and I click on Lisa and I say deed without an S and I update, see now it's Lisa deed without an S. And basically if I refresh the page, see it still has deed without an S because it sent the update to the server. So that's what I just showed you. This is the jQuery Ajax approach. They give you a Ruby class called HTTP, and it has all of those methods that you normally expect from jQuery Ajax, and it does everything. You just have to pass it all the parameters manually yourself. But it lets you handle more advanced web requests if needed. And I'm not going to cover Axios or fetch. Everybody knows how to do that. Whatever you can do in JavaScript, you can do it in Opal Ruby. So that's what it is. Oh yeah, this is an example of HTTP GET, which gives us a response, and then we need to use a native class to wrangle the data, but that's what the resource service handles for you automatically, so you don't have to do that yourself, but it doesn't matter. This is just a quick example for how to do more advanced web requests. And then there's integration with JavaScript libraries, so you can either integrate with JS libraries that are in your Rails directory. You would just do require vendor jQuery, and it'll automatically load jQuery.js from the vendor directory under your Opal directory. So this will load it from your vendor directory. Here you can just link to JavaScript indirectly by declaring a script tag in your HTML, like in your layout, and then that's how we link to a library like highlight.js. For example, the Glimmer sample selector that I just showed you adds these two links, and then it basically here in the highlight code method in its presenter, it links to window.hljs, which is automatically provided to you when you load those two links, and then it says highlight all. So this is what basically you saw here. So if I go actually to the main app, so when I click on one of those, it basically will load the data from the back end, and then it'll automatically call highlight.js, and it'll convert it to a syntax highlighting. So that's what we see here. We see syntax highlighted Ruby. So that's that. As far as performance, that's a good question. In my experience, Glimmer DSL for web can render 1,000 elements in about 50 milliseconds on a MacBook Pro 14-inch 2023, which is from 2 years ago. So that's more than fast enough for most business apps. Honestly, in my job Rails application, which is a fintech application, I checked all our web pages, and the web page with the most elements had only 1,200 elements. That's it. So almost 1,000 elements, and they get rendered in 50 milliseconds, which is super fast. So that means front-end Ruby is fast enough. Like even if JavaScript with libraries that are like over-optimized in JavaScript might be faster, it's not needed. We don't need that. Like for example, we don't use C in our web server. We actually use Rails. Like we like to use Ruby in our web server because we care more about productivity. It's more important to finish work fast instead of having the code run fast, because the code is running fast enough in Ruby so that we don't have to write C or C++ code. So this is the same way in the front end. We don't have to over-optimize the front end. It's already fast enough in my experience. And the web recommendation is to be under half a second to a second, which is way more than this. So honestly, this is fast enough. So in my experience, it's not an issue. So let's look through, I mean, I'm pretty much done, but let me look through more samples. Well, I mean, I guess I covered enough samples. I'll show you one more. This one, okay, this is a very simple sample where if I click here, it gives me an alert. And here it's just a div, wait. It's just a div with a button. If I click, it's an alert. Double dollar, sorry, is actually window. Like it's accessing the window object in JavaScript. Let me see, what is it that, no, I think I showed you enough examples. This is SVG. It's just showing that SVG is supported too. Yeah, that's it. So if we, okay, to summarize the benefits of Glimmer DSL for web, programmers don't have to waste time unnecessarily splitting resources between multiple languages like JavaScript, HTML, CSS, Ruby. If you can write all the code in one language, you could be a lot more productive. That's been confirmed in my experience. But at the same time, if you need to support CSS externally, it's also possible. So you have the best of both worlds here. Programmers become happy because they're using Ruby again. Like we're not stuck with weird JavaScript paradigms. We can write real Ruby OOP now. So we can write natural code that reads like English again. So we're not stuck with badly engineered JavaScript libraries or over-engineered or premature optimization obsessed libraries like React, Angular, Vue, etc. We're not fighting also JavaScript build issues like Webpack anymore. So that's another benefit. Customers are provided with a better experience because a lot of the time we can also short circuit or avoid, sorry, HTTP web requests if we can reuse some back-end Ruby logic directly in the front end. So that way we can do front-end calculations directly using the same code we have in the back end without spending extra effort. So it saves us from even more wasted time. Front ends are built in about half the time in my experience. So that means 12 months of work every year in React will be done in 6 months in Ruby. Honestly, in my experience, that's like, that's totally true in my experience. I mean, I end up with about half the code of what I have in React if I add up the model and presenter layer as well to the view code. Also, I'm able to solve problems faster because I'm not stuck fighting Webpack issues or fighting React state management issues. I just write the same kind of Ruby code that we love to write on the back end, except I write it on the front end in the model layer. And then finally, companies can cut their hiring budget in half by having back-end developers do front-end development and becoming full-stack developers. And that's it. So what's the future? There will be a Glimmer router DSL for the front end. So yeah, that will be supported in the future. We will integrate with the ability to support HTML web components. So HTML web components is a general standard for front-end components. So this is just Glimmer supporting the ability to reuse HTML web components built in other libraries in JS. So that means that'll open the door for being able to reuse React components in Glimmer directly, which would be useful for me and my job because we used to use React in the past. GRB is a flavor of ERB on the back end. So in the back end, we can take the benefits of Glimmer to the back end. So instead of writing ERB files, we'll start writing GRB files, which is Glimmer RB, which lets me write the same code that I showed you that's like in one language for structure, logic, and style on the back end, not just the front end. Also, server-side rendering of front-end web components. So if I build components for the front end, I can pre-render them in the back end first. So when first loading the page, we would render them from the back end and from Rails directly. And then when the user interacts with the page, they start interacting with the front end, like with the JavaScript listeners, like onClick, on mouse up, on mouse down, etc. So that way we will be able to bridge the gap between the back end and front end even further. This is a huge one. This is a very, very big one that I really look forward to. Connect front-end models with back-end models. Okay, this goes even further. So once we connect the front-end views to the back-end views and be able to re-render views from the any front-end views can be re-rendered in the back-end. So once we're able to do that, then I might decide to short-circuit the ability to write APIs in Rails. So right now we have to write a controller, and it has to connect to a model, and the controller has to follow REST. And it feels like boilerplate code, honestly, at this point, because if the front end is Ruby, why not just talk to a proxy object that represents the back end? So if I have, for example, a collection of, let's just say, in my app, in my fintech app, we have debtors. So if I have a collection of debtors, and I want to look up the debtors of a company, instead of building a REST API and calling a REST API, if I have a debtor class in Ruby on the back end, I can expose a debtor class in the front end and just call debtor.all in the front end, and it gives me the debtors, and it basically does everything the REST API does automatically. So then we don't have to even write controllers in Rails anymore. We can kill that part of Rails. So then not only are we saving effort by not writing code like React, which will half the effort by half, we're also not writing as much back-end code as well. So this will basically enable us to do 12 months of work in 3 months with this improvement. So that's another thing that I really look forward to exploring in the future. And it's only possible because we're using Ruby in both the front end and the back end. Consider supporting Ruby WASM as an alternative to Opal. So WASM is another runtime that's an alternative to Opal. The reason I picked Opal over WASM is Opal downloadables are in kilobytes only. WASM downloadables are like in megabytes. I think it's 9.5 megabytes. So this is good for people with fast connections, like at a company, like if it's employees at a company. But for the general public, like normal users, you probably want to use Opal because it's faster, because it has much smaller downloadables that are like just kilobytes. And then finally, explore a DSL of Web Canvas API and integrate with WebSockets. Of course, that's definitely needed. And that's it. Thank you, everybody. This is the Q&A phase. And if you want to scan this QR code, you can get the slides. And here you can check projects that you can star. And also you can check previous talks that I gave on this if you want to learn more about the project. Thank you, everybody.